Okay, welcome back everybody to video 2. We are going to continue on with the Algebra 2 final exam review. We're going to pick up at problem number 13. So in this set of problems we are simplifying radical expressions. So this is where we will branch these off. So we need to find a perfect square that goes into 60. Well, that would be 4 times 15. So if we break that up, we have the square root of 4 and the square root of 15, so we have a final answer of 2 square root 15. In a problem like number 14, we have 4 square root of 2 times the square root of 18. Well, easiest way that I see to do this is to multiply the two radicands together. Well, 2 times 18 would get me 4 square root of 36. The square root of 36 is 6, so 4 times 6 equals the whole number of 24. When you are dividing two numbers that are both underneath a radical, then you're really being asked to take the square root of the top and the square root of the bottom. Well, the square root of 225 is 15, and the square root of 289 is 17. So my answer would just be 15 over 17. Moving on to the next section, this is where we're going to be solving equations involving square roots. So if we have a single variable equals, so x squared equals 289, then we have really, the only thing we have to do with this is take the square root on both sides. If we take the square root on both sides, we get x equals plus or minus, well, that happens to be a perfect square, which is 17. When we have an equation to solve like in number 17, again it's equal to 0. So now in order for us to do this, we need to solve and get the square by itself. So we're going to add 36 to both sides. So we get 3x plus 1, the quantity squared, equals 36. Now we need to get rid of the squared, so we're going to take the square root on both sides. But remember, the square root of 36 is both positive and negative 6. So we have 3x plus 1 equals plus or minus 6. So we branch this off into two separate equations. 3x plus 1 equals positive 6, and 3x plus 1 equals negative 6. And your job is simply to solve those two both for x. So subtract 1 on both sides. This one gets us to 5. This one gets us to negative 7, and divide everything by the 3, so I answer of 5/3 and an answer of negative 7/3. Moving on to number 18. Again, we need to isolate everything that has the squared on it. We need to isolate this, so we need to get rid of the 1/2. Well, easiest way to get rid of 1/2 is to multiply both sides by 2. So that leaves me with x minus 4 squared equals 16. Get rid of that. So now we're back to where we were with problem number 17. We're going to take the square root on both sides. So we get x minus 4 equals plus or minus, well, the square root of 16 is 4. And then we branch it apart into two problems. So x minus 4 equals positive 4, and x minus 4 equals negative 4. Solve both for x. The first one comes out to be x equals 0, and the second one, x equals a negative 8. And there's your two answers. In a problem like 19, we're going to divide both sides by the 3 to isolate the x squared. Then we get x squared equals a negative 27, but now this time we have a negative. So when we go in here and we take the square root on both numbers, well, two problems here. Number one, it's negative. Number two, it does not have a perfect square. So we need to deal with 27. 27 is negative 9 times positive 3. If we square root these both, well, the square root of negative 9 is going to be 3i, because remember, I takes out the negative under a radical. And then we would leave the square root of 3. And all we have to do to finish is put the plus and minus in front. Our next two problems, we put stars next to both 20 We said 20 and 21 were both probable questions for exam questions, so let's take a look. Again, our job here is to isolate the square. So we're going to divide both sides of this by a -6, which leaves us the quantity x plus 5 squared equals -20. Now we're back to like we did in number 19. We're going to take the square root on both sides. So on the left side, we're left with x plus 5. On the right side, well, we have to think about, if I were to break up 20, 20 would be 4 times 5. But because it's negative, we'll put the negative with the perfect square. So the square root of -4 would be 2i with a square root of 5. So that plus or minus 2i square root 5. But I still have this -5 over here to do, or the +5 over here, which means we're going to have to subtract 5 from both sides to get this to cancel. Well, this 5 cannot be subtracted from either of these two because it's not a common term. So we would write this as -5 plus or minus 2i square root of 5. In a problem like 21, we need to again isolate the square, so we're going to -9 from both sides. That leaves us 2x squared equals -50. Divide both sides by 2, so we get x squared equals -25, and then we'll go and take the square root on both sides. But in this case, at least we got lucky in the fact that 25 is a perfect square, so my answer is x equals plus or minus 5i. The I brings out the negative. The square root of 25 is just 5. Then we get into the actual I questions, the imaginary questions, dealing with complex numbers. I mentioned to my students to remember you have real numbers, you have imaginary parts. We're going to add the reals to the reals. Well, 6 plus 5 is 11. And the imaginaries to the imaginaries. 2i plus a -1i would be plus 1i. And that would be your answer. When we're subtracting, as we talked about in class, we're going to do the little keep change rule. We are going to change the subtraction sign to addition, and we're going to change all the signs for the numbers that come after. Then we can go ahead and add as usual. So that means we have 2 plus 10, so we would have 12. And then our imaginaries, -6 plus a -4 would get us a -10i. In 24, you're being asked to FOIL. So we're going to practice that real quickly here. So FOIL this out. First, we binomial times binomial. First times first. -1 times 11 is -11. -1 times -i is positive I. 2i times 11 is 22i. And 2i times -i is -2i squared. Remember, I squared is equal to a -1, so really this problem looks like this. -11 plus, combine these two, whoops, my apologies. Let's get back into that. So we have -11. If we add the two together here, we get plus 23i minus 2, and in place of the I squared, it's times a -1. Well, -2 times -1 is a positive 2. Let's bring everything else down. And now we have like terms at the beginning and end. -11 plus 2 would get me -9 plus 23i as a final answer. Now, out of all of these, the question you are most likely to see, because it involves not only adding and subtracting like terms and foiling, but it's the division question. So this is the one you should definitely be ready for. The trick to these, of course, remembering that you have to multiply the top and the bottom by the complex conjugate. That is taking whatever equation's in the bottom, and we are going to multiply the top and the bottom by the opposite of this. So instead of 9 minus 4i, we're going to do 9 plus 4i. So the way that I taught my students to deal with this is to deal with the top and the bottom separately. The top says to FOIL negative 7 plus 6i times 9 plus 4i. So we FOIL. Negative 7 times 9 is negative 63. Negative 7 times 4i is minus 28i. 6i times 9 is a positive 54i. And 6i times 4i is a positive 24i squared. So again, I'm going to move this bottom part over. We need to do two things. We need to combine like terms. So we'll combine those two. So we have negative 63 and negative 28 plus 54 is going to be positive 36i plus 24i squared. The I squared will go away and change the sign of the 24. So we would have negative, then we'd have to add up negative 63 plus negative 24. If we add those two together, we'll end up with negative 87. Oops, sorry, did a little calculation wrong. 54 and 28, that's going to come out to 26. Sorry. So we would end up with negative 87 plus 26i. That's the top answer. But we still need the bottom part. But the bottom says we're going to FOIL 9 minus 4i times 9 plus 4i. Well, this is a difference of squares. So the only numbers we have to do, first times first, is 81. Last times last is negative 16i squared. Get rid of the I squared, change the sign of the number in front. Well, 81 plus 16 gets me to 97. So I get a final answer of negative 87 plus 26i over 97. Again, this problem is the one we're going to use because it incorporates a little bit of everything that we're doing. So let's keep moving forward here. On to the next part. Solving with, whoops, we missed something in here. Maybe not.